So next up, we have Henri Thevenot. He is currently a digital manufacturing portfolio development executive at Siemens Digital Industry Solutions. Throughout his career, he has led major digital transformation efforts. At GE Transportation, he led the PLM and ERP strategy and implementation as Lean Six Sigma Master Black Belt. At GE Aviation, he was responsible for the digital strategy for engine manufacturing, repair, and overhaul sites. In his current role, he is leading the digital manufacturing product portfolio strategy to enable the digital transformation for aerospace and the defense industry. With that, I'd like to introduce Henri to please deliver his presentation. Thank you.
Thanks for the intro. So when I was asked to come and speak today, I was thinking about what's bringing us here in the room today and on the phone, right? And one thing I was thinking about, I think, is around complexity. If I rewind back in my role at GE Aviation and manufacturing, a lot of things that would keep us awake at night around engineering, releasing brand new designs, and then we manufacturing have to figure out how to make that happen. They would release things within lead time. We have pressure from leadership to deliver parts. We don't know if we have the right equipment. We don't know if we have the right tools or the right skill sets. And then we have to figure it out on the fly. And once when we figure it out, by then engineering has released new changes and we have to keep churning, right? So it's like this constant madness of trying to keep up with those changes. And things are not getting easier. If you look at products that we're making, I'm sure you're making, they are more integrated, right? So I was thinking about it on the way here. 20 years ago, if you asked me what a car was, it was probably a mechanical product. And then I got a Tesla as a rental. It's everything but mechanical. It's software, it's electrical, it's electronics, and then mechanical as well. So we have more complex products. We have increase in competition, pressure, time to market, increased in flexibility needs. And so with all this complexity, really, we're trying to figure out how we can help with this. And so what we're seeing with the companies we're working for, and I'm focusing on aerospace and defense companies, but it's the same across industries. With companies that are looking at the complexity as a threat, and they're really, really trying to address it just to survive, right? So just to get by. And then we have the other ones that are seeing this complexity as an opportunity to actually jump in both feet and embrace it and use this as a competitive advantage. So in the Siemens portfolio, we have what we call Accelerator, which is really a suite of solutions to help embrace this complexity and turn it into a competitive advantage. So at the highest level, you're familiar, really the key is creating this digital enterprise. So what we mean by digital enterprise, it's really having this combination of both your real world and your digital world, not just for the product, but for the production process as well. So again, being able to have this digital enterprise to support early design of both product and productions, do all these validations, leverage that information as you're ready to start making parts or assemblies, and then be able to use that information from the shop floors, from your equipment, from your product, to be able to gather data and insights to feed it back and support continuous improvement. So again, a lot of the companies we're working with, and it's not poke of anyone, right? But it's really the world we're seeing and we're living in is a lot of the time, again, what we're seeing is there's a lot of, I would say manufacturing is typically an afterthought, right? So engineering will iterate on the design of the part of the product. It's great. And all of a sudden we'll throw it over the wall to manufacturing and you guys go figure it out. And again, typically we're trying to bring in manufacturing earlier in the process, but it's hard. It's hard because you don't have the tools to really understand and assess the impact of a design change on manufacturing. You may have disconnected systems, or you may not have the right capabilities to quickly do that. And then you're asked to figure out if you can do something, right? So again, trying, but what's happening a lot of the time, what we're seeing is you're getting into the point where, again, engineering release a change, and then you have a cut and try approach, right? So you will just basically try to make it and figure out the process on the fly as you're making it for production. So results in rework. Rework is cost and extended lead time. The approach that we have with this digital enterprise and digital twin of the production is what we call shift left. And it's the idea of being able to move the, I would say, manufacturing decisions and optimization as early as possible. And ideally, you're doing concurrently with engineering. So again, as engineering refines the design of the product, you can refine the design of the production process, provide feedback every step of the way. So again, you iterate. So by the time you have completed the design of the product, you should have a very good baseline of the design of the production process as well to support production. And again, the idea is to minimize rework, which is again, shrinking lead time, time to market, and cost as well. So the way we approach it at Siemens, and we create for the creation of this digital twin of the production process, we have a digital thread, which is really weaving all this information every step of the way from very early conceptual designs all the way to shop floor productions, all the way back to production support as well. So again, so we have this concept, so we call intelligent manufacturing digital thread, which is really creating that information and helping every step of the way from design, realize, and optimize. So if you look at what we mean by those phases, if you take the first one, the design one, again, this is where we really feel there's a lot of opportunities to make improvement. We're all familiar with engineering having extensive simulation tools to help optimize the design of a product. We want to be able to do this on the production process side as well. So same way engineering iterates on their design, we want to iterate on the process itself, and to the point where we are comfortable that we are de-risking the production process. The second thing is, once we have that production plan complete, we want to be able to reuse this and leverage it to support the shop floor production. As Sudhi was mentioning earlier, this is where a paperless router will come in, right? So again, in the past, since several companies, it's very hard when you have disconnected systems. So you have to either manually type, update information, create bill of materials, create process plans in one system, and then engineering is constantly changing things. And then other ones are even less mature on their digital journey. Well, then you print, you have paper routers, right? That's all of a sudden now you have to chase things around the shop floor because one change is made and you have to update those systems and you have to update and redline all those copies everywhere. So again, the idea is to be able now with this digital thread to reuse that design information, integrate and support your shop floor operations without having all these manual interventions on typing data or running around and updating things. The other thing that we have in the realize phase, I guess Sudhi mentioned that around the constraints-based scheduling. So once we have a full definition of what needs to happen, and we are comfortable that we can make it happen, we have assumptions, right? You always have, assuming you have the right resources and the right materials. So we have capabilities to now take real-time constraints on your capacity, whether it's hard capacity or soft capacity. We have ability to take your constraints around your material availability and the priorities of the work coming in within your factory to optimize the schedule and the sequencing of the different activities within your factory, again, to optimize the resource utilizations and deliver on time. And then the last one is around the optimize. This is where IoT 4.0 comes in, right? So once you're in productions, how do you now be able to get data from the equipment, from your products as well in the field, and be able to learn from this, so gather insights, whether it's real-time analytics or whether it's maybe AI and predictive. How do you use that data so now get insights to feed it back and support, I would say, continuous improvements of both the product and the process as well. So just want to give an example, a couple of videos, right? So say you're designing a new airplane wing here, or airplanes, right? Then the idea is as engineering starts their designs, we want manufacturing to be able to start thinking about their process. So sequencing of operations. Am I going to be able to build these things with the sequence I'm thinking about? You want to start thinking about capacity, right? So you know the ramp up requirements from a production standpoint. You may not have all the equipment yet, but can I start looking at different alternatives for my layouts, for my flows? Would I be able to support the ramp up that I need to make that product? You don't have to have any specific definition. You're just doing a lot of I would say, capacity planning. As you start refining the design, then you can get a lot more granular. You've done assessment around the capacity that you need. Do I have the right capabilities? Can I do simulation of specific manufacturing processes? Again, whether it's more traditional, maybe machining, or maybe you have technologies more advanced like composites or additive. You also want to be able to do studies around ergonomic studies, right? I'm sure you have some part of the process that are some manual. So do I have the right clearance to install something? Do I have the right clearance to move parts around in my factory? And use all this information, you can leverage VR as well to get immersed into this. And again, you're doing all this concurrently from engineering. And if you find anything, be able to feed this back to engineering real time. So I'll just pause here for a second. So a couple of examples I can think of, as simple as it sounds, we had, customers that were getting significant improvement by just having access engineering designs early and be able to make simple studies around assembly, sequencing, and be able to just say, hey, now, if you make this opening larger, I'll be able to either install this part through faster and minimize damage during the installations. Can you make the opening larger, right? So this type of simple feedback help iterate on the design and help make sure that you are able to release a design that you can make. The other thing that was mentioned earlier around model-based definition, right? So now we're back in the engineering world. Engineering will have PMIs on their models, really pushing for this. How do you reuse that information? Again, connected digital thread, not typing in information. And so this is where we have capabilities to take this information here. And then what you see now is the planning solutions. So you're directly getting the information from your engineering models. You're getting the PMIs. You can use those PMIs, for instance, to create inspection definitions. So as you work on the plan, on the process plan, and you have inspection operations, you're directly using, again, information from engineering, from the model, all the way down to the shop floor. When you get on the realize phase, again, we want to make sure we can get that information now and be able to support production. So again, back in the planning tools, you're able to leverage the 3D, you're able to leverage PMIs, additional informations to support your plan. Again, it's connected. So if engineering changes something, you can quickly understand the impact and you can adjust it as needed. What you see now on the right-hand side, this is the Siemens manufacturing execution systems, the MES that we have. Again, not typing data, it's integrated. So once the engineering data is released, once the production process data is released, you push this in the execution system, and this is where your operator will be interfacing with to support your day-to-day operations. So they have all the instructions that they need. This is where they will be able to perform their data collections, inspections, etc. That's part that you're more familiar with. So this is on the execution side, using as well your digital twin of the productions to start the commissioning of your equipment, right? So you have your digital twin of your CNC machine, your HMI, your PLCs. How do I take this and I start using that to commission my equipment? Another thing that is that is a key concept, and I think Sudi also mentioned that, it's what we call closed loop manufacturing. And the idea is now you have this digital twin, but you're on the shop floor. You want to be able to get any issues from the shop floor back into the digital world to be able to quickly assess, do a root cause and corrective actions and address it. Again, no more maybe redlining or maybe doing a red tag, putting a partner on the side and calling quality engineers to figure out what's going on. And there's a lot of emails, phone calls to figure out what's happening. What we're doing now is, again, because your execution system is, again, tied to the digital twin, when a shop floor operator, for instance, raises a non-conformance, raises a defect, that information go back to the digital twin of your production and the process. The operator doesn't have to specify, which part, which assembly, which revision, which process. It's all in the system. You just say, I have an issue here. That information behind the scene is brought back again. So a quality engineer, a manufacturing engineer can then use that information to be able to understand what's happening. We have capabilities around, root cause and corrective actions as well. And then if there's an update on the product, that can be sent to engineering, or an update on the process like shown here, that can be done in the tool as well. Here, we're just showing a quick example. We'll just say, hey, we're going to add an operation. Let's get this operation that will fix the issue. We're going to get this pushed back to the MES. And then next time the operator comes in now, the instructions has been updated to reflect that change, right? So again, there's no more chasing around things on the shop floor. It's all there, and they can continue their work here. The last phase around the optimize, again, this is where IoT come in. So again, now that you have this digital twin of your productions and you have real world data, a couple of things that we have in our portfolio. So number one is being able to access data for real-time reporting around your KPIs, output, throughput, defects, etc. So that's one thing. But what we also have is a platform called MindSphere. So this is our IoT and analytics platform to have with a artificial intelligence built in. So you can start doing some use cases around, for instance, condition-based monitoring, condition-based maintenance. So being able to look at historical data, take that data to predict when things will fail and start, doing maintenance proactively. Other things that's not shown here, but the other idea that we have is, because you have this digital twin of your production process and you're collecting data on the shop floor, the idea would be, if say there's a hiccup in the productions and there's an issue in the output over the past 2 weeks, and you're trying to figure out what happened. Well, real life, it's hard because there's a lot of things that happen. You can take that data, plug it back in your model of your the digital twin and play and hit replay in a sense. So you're kind of replaying what happened and trying to understand what caused the issue that led to maybe a decrease in output. And the last thing you can also do, again, take the shop floor data and be able to feed it back in your models to, again, increase the accuracy of the digital twin of your production. So if you want to run more what if scenarios, you have these capabilities as well. So a couple of the examples, again, with my background, I'm mostly aerospace and defense focused, but really it's across industries, right? And the CSS shared some of that today. It's real. What it's seeing a significant improvement in touch times, in cycle time, productivity, because again, having this information connected is really helpful and to not only design but also reuse as well. So again, some examples here. The key, I think, as I brought it here again, with my background, aerospace and defense, we can have several slides like this with different industries, but the key is, probably some of you are thinking Siemens is this large monsters company, right? A lot of, it's big, but we are helping companies of any size. We are helping those large and more established companies, but also a lot of startups as well. They are, some of them are here, where again, we have companies coming to us and helping from the get-go. How do we start this digital transformation? So help us from the beginning so we can scale the solutions and we can scale where to focus on. So it's not just everything. Just again, wanted to share that here as well. Just one example here, Sierra Space. So we want to just startup-ish, about 1,000 employees. They are growing quickly. They are building the next space plane, placement of the space shuttle. They came to us last year and now they're all in, right? So talking about complexity again, this is what they are looking for is they really see this digital enterprise as a driver for them to be first on the market. And that's they're seeing the value, and from the top they have embraced it, and now they are moving onto a Siemens accelerator platform, both on the engineering and manufacturing sides, and then looking at those videos, but we're doing it internally. Again, this is what they see as their way to be able to be the first on the market and be able to meet the cost and schedule constraints that they have. A couple of things here around what's next, right? So I showed the digital threads well, the idea is really to keep extending it. So if you look on the left, what we are is really, we want to be able to be involved even further earlier in the design cycle when you may not even have any idea of the representation of the products, right? So engineering works from with model-based systems engineering. We want to be able to start in being involved there and doing some assessment on manufacturing very early in the design stages. On the right-hand side is the other end of the spectrum. Everything I've shown you here works great if you're assuming that the parts will be coming in on time, you have the right resources available. But really, especially those days and age, right, with the supply chain disruptions, how do we now extend the digital thread within the supply chain, within the supply base, so you can get insights from your suppliers, so you can start again reacting short-term and long-term as well if you need to make decisions, right? So we are expanding the portfolio to look at how to integrate with the supply base to gather these informations to help further improve the day-to-day operations. And then in the middle, again, is we are looking at flexible manufacturing. So a lot of complexity around the products and how do we use equipment to be able to reconfigure manufacturing cells to support the production needed for that day. So again, how do I further optimize the resource availability within the four walls? I'll skip this. And this is really what I had for you today, and just want to leave you on that note. So I joined Siemens a year and a half ago. I was at GE for before. We've been using Siemens products for a while, but what I say is once I joined, I realized that there was a depth and breadth of capabilities of solutions that I didn't know exist before. And if I had known that there was such capabilities, likely it would have probably removed some of my headaches back then and make me sleep a little bit better at night. So I'm hoping that with this presentation is very high level, but that resonates with you. And if what I would encourage you, if you have any specific manufacturing challenges that you're trying to address, would love to have a discussions, reach out, see, hopefully we can help partner and then, address those headaches. So hopefully you can also sleep a little bit more sound at night. So that's what I have. So thanks for your time again. And then on this, I'll turn it back to Nassim. Thank you.